Okay, as I was saying, the session is yours alone. Oh, not yours alone per se, but you're the one to lead us through. And let me repeat this. If you have any questions along the way, kindly write them down or note them down in the comment section. I will sure be able to read them out. So yeah, Kevin, take your time. Yeah, and welcome.
Thank you, Valentine. Am I audible?
Yes, you are.
Okay, thank you. So, as you have heard, my name is Kevin Kiprotich. I'm an alumni of JQuat and a member of GeoCode, currently working as a GIS developer at Locate IT. So, I'd like to first take this opportunity to thank my colleague Valentine for the opportunity to teach and to share some knowledge in the field of machine learning and its applications in GIS and many other fields. So, before I proceed, maybe I can start by sharing the course curriculum, what we are going to learn over the time that we'll be together. So, let me just share my screen. I hope you can all see my screen.
I don't know if it's on my end alone. Okay, Sammy. Thank you.
Okay, if you can see what I'm showing, uh, yeah. So, David, is the Zoom okay? Great. So, the curriculum that we are going to undertake probably will span over a few months and maybe due to changes, especially with regards to the time that we are meeting, because the course content is quite large. But we are going to first of all start with the basics, and in module one we'll be tackling some of the definitions and applications of machine learning. We'll also have a recap of Python itself, so that we get familiarized for those who haven't interacted yet, and for those who have, but it's been a while, so we will have a refresher on Python. And then module two will be focusing on data processing. I don't know whose mic is on. Val, is your mic on?
Oh, sorry.
Okay, so in module two, we'll be focusing on data processing and some of the techniques that is used to prepare data before machine learning algorithms are applied. And particularly, we'll be focusing on data collection and data cleaning. We'll be focusing on data transformation and data splitting, which are key concepts in preparing your data for applying machine learning. So under module three, we'll now start working with the specific machine learning algorithms like linear regression, logistic regression, decision trees, and random forests. We'll interact with the SVM. We'll also interact with the neural networks. I'll have to give a hint on some concepts in deep learning. And then in module 4, we'll be interacting with the unsupervised learning, looking at concepts such as clustering, dimensionality reduction, anomaly detection. Under module 5, we'll be learning how to do model evaluation and optimization. Um, we are going to learn how to use concepts or metrics like the confusion matrix, ROC, bias variance trade-off. We are going to learn how to do hyperparameter tuning, how to look at overfitting and underfitting. And then, if time allows, we'll look into time series analysis using the ARIMA and SARIMA model and forecast with the machine learning. We are also going to work on projects. So particularly, we will focus on projects related to GIS because I want to believe most of us here are in the geospatial world. So we will look at two major applications like predictive modeling and classification. And also we'll have a look at how we can break down a project so that it doesn't seem enormous. So how do you formulate a problem definition? How do you do the data collection? How do you build your model? For this course, we will not look at deployments, but obviously machine learning doesn't end after you have done your analysis and you are through with the optimization and you're through with optimization and you are okay with your evaluation metrics. So there are further steps that can be taken once you have built your model. So for example, if you want to share your model to be used by others, then it needs to be accessible via the web maybe. So that is where deployment comes in. But for the sake of this course, I wouldn't want to go deep into the deployment. I want to emphasize mostly in how to generate machine learning models, how to evaluate them, and how to make each model useful in any field that you're working on. So this is the course curriculum. I will share this via the WhatsApp group, and I hope we are going to all interact well. Feel free to share your questions via the group, and also you can reach out to me or Valentine if you have any questions. So, for the sake of today's class, we are going to have a brief intro in what is machine learning. So, I'm going to quickly switch. Allow me to switch to a small presentation. I hope it is visible. Can everyone see the screen?
Yes, we can.
Okay, I hear someone would like to speak.
Interesting. I can't see anyone's hand up.
Ama ni message tu pop up hapa. If you wish to speak, kindly you can raise your hand so that we can allow you to proceed. So, what is machine learning? So, the Oxford Dictionary defines machine learning as the use and development of computer systems that are able to learn and adapt without following explicit instructions by using algorithms and statistical models to analyze and draw inferences from patterns in data. Ideally, computers cannot think on their own. So they need to be trained, they need to learn so that they can do tasks, they can perform tasks, and they can they can adapt without necessarily having to pass instructions directly. Am I audible?
On my end, you are. Um, I don't know about Othiambo. He's saying voice not quite clear and audible. A couple of people are saying that they can hear you.
Okay. Sawa sawa. So maybe you can check your internet or something. Maybe there's an issue there. Okay. So, like I said, machine learning enables a computer to think, that is one, and adapt to and be able to perform tasks without necessarily passing instructions. You can think of it this way. Uh, when you have to key in values into a document, for example, you are typing, for example, this PowerPoint presentation. The ideal process would be to pass instructions to the computer in terms of what you want to be able to be visualized under PowerPoint. And this can be through typing, for example, using your mouse. So you are ideally passing instructions to the computer. But now machine learning comes in to automate, I'd say, to automate the process so that the computer does the tasks for you directly. And I'd like to break down machine learning into three categories. We have the first one, which is supervised learning. And this one, you can think of it as the name suggests, it's learning under supervision. And you are providing data to the model that you are training so that it can generate um, I'd say outputs. I'd like to call them outputs based on the data that you have fed it. So, for example, you can think of it this way. If, for example, you want to create a model that can be able to detect uh, a disease from a plant, you would ideally have to pass pictures to the model of different diseases and how they look like, so that once you provide a new picture, the app or the model can be able to tell you which disease this plant is affected with. And the next one is unsupervised learning, which is the opposite of the supervised learning. In this instance, you don't provide training data. So the model learns from the input data directly. So for example, um, you would want in the remote sensing world, when you are trying to classify an image to generate land use land cover types. So this would work by getting the image itself, and then based on the values that the image has, it will generate patterns and structure the data that is provided to come up with an output. So here you are not providing the training data. You can think of when you are doing supervised classification in remote sensing, you provide, you tell the computer that this particular place has built up, it's a built up area. This other particular place is a water body. We have grassland here. In the other instance of unsupervised learning, you just pass an image. So you don't necessarily train it. So the goal here is to identify hidden patterns or structures in the data that you have provided. And common algorithms under this include the clustering algorithm. We are going to look at it. So the big terms, zisiwasumbue. We have an algorithm, for example, the k-means clustering, the hierarchical clustering. We have the principal component analysis. So we are all going to look into this as we proceed. Now, we have another one that we are not so familiar with in the geospatial world, and this is a type of machine learning known as reinforcement learning. And in this one, the process kind of behaves like how you train a pet. So, for example, when you train a dog, maybe you train it by rewarding good behavior and punishing bad behavior. So this one works in the same way. So the model learns by interacting with an environment and receiving feedback in the form of rewards or penalties. And the goal is to learn a policy that maximizes cumulative rewards over time. So we are not familiar with this one so much in the geospatial world because it has greater application in things like game development and robotics, and there are others. But you can ideally think of it as training a pet. So you train by rewarding good behavior and punishing bad behavior. So some of the applications of machine learning include the few that I've listed here. We have content recommendation. Um, we have, you can think of, for example, TikTok, for those who have interacted with it. The algorithm that supplies the videos that you watch, you would notice that the videos that you watch have, they're kind of similar. So if you like, if you are a person that is into games, for example, you would get your feed would be filled with games. If you like music, for example, your feed would be filled with games with music. If you like dances, your feed will be filled with dance videos. So that is what is done under content recommendations. And also, this is a common thing in movies, for example, in Netflix or any social media website or application. So machine learning aids in the generation of videos or content that a user has been frequently interacting with. We have common examples in the GIS sector, that is disaster management, by doing something like the susceptibility mapping. For example, when you want to know the areas that are susceptible to floods, for example, the areas that are susceptible to landslides. So you would ideally use machine learning algorithms to provide insights into areas that are susceptible to these particular disasters. And we are going to work on a project. We're going to work on project, particularly dealing with flood susceptibility mapping. We have another application in agriculture, um, crop yield prediction. We have applications. Val, you are clapping because your project was on crop yield prediction. We have applications in shopping. So I don't know whether you have noticed this, but once you start shopping on an app like Jumia or Kilimall, you would notice that the things that you are searching are the ones that you would be seeing when you are visiting the app. So you get personalized recommendations for the things that you need to shop. We have autonomous vehicles. We have game development, and in machine learning the application is limitless. So you can literally do nearly anything with machine learning. You just need to be creative and imaginative. So that was a brief intro into machine learning. And as a preparation to next week's class, I don't know whether we'll be having a class next week. Val, what's the
Yes, we will do so. We will have one same time, same day. Yes, on Sunday, same time.
okay? There's a question by Muitaben. How is machine learning application in autonomous vehicle development? Yeah, you can think of self-driving cars. That is what autonomous vehicles mean. So a car that can be able to detect a lane, for example. So this is usually done with using various technologies. For example, LiDAR. So a car can be able to detect things like speed bumps on its own based on the input that it's getting from a LiDAR scanner, for example, so that it prevents hitting other vehicles, um, so that it can maintain the lane that it is in while on traffic. Um, you can think of a car that can follow a route that is provided by either Apple Maps or Google Maps. So autonomous vehicles are developed to navigate areas or towns or cities anywhere for as long as there's a road, but it is driving itself. So you can think of it as self-driving vehicles. I don't know whether I've answered the question. Do we have any other before I proceed? You can type it kwa chat or you can raise your hand so that we let you speak. Okay, so if there are no questions, we all need to have the we all need to have these three things when we are doing the course. We will need to have Python installed, we'll need to have Jupyter Notebook installed, and we will need to have a Python virtual environment. So I'm going to do a quick demo of how to, let me do a quick demo on how to install Python for those who haven't interacted with it. So if you search on Google, if you search Python, Then you go to downloads. You'd be able to see this. So you can download the setup from there. I'm going to copy this and paste it in the chat. So for those who don't have the link, you can follow it from the chat. So this is what I want everyone to do once you have installed the setup. So you will access the setup and you will run it. And before installing, add there's a checkbox at the bottom there that says add Python to path. So you will click that and then you will click install now. But for me, I think I have Python already installed. So once you click install now, the process will proceed to install Python for you. So for now, I'm going to cancel. Then I'm going to open command prompt. Yeah. So you can open command prompt from your side and then you type Python once you have installed Python into your system. So if you click on it like that, it will open a Python console that you can use to interact with Python itself. And here you can run various Python commands like that. For example, I say print hello world. So you can run Python commands from here, but this is done line by line. So for now, I'm going to quit. And then once you have installed this, we will need to install now Jupyter Notebook. So to install Jupyter Notebook, you can install it directly using the Python's provided command to install Jupyter Notebook. And I'm going to type it into the chat. So you are going to run pip install notebook, and this will install Jupyter Notebook into your system. So it has a lot of dependencies, especially if the Python version that you are using is new or you haven't yet installed any package into Python. So this will install Jupyter Notebook into your system. Val, you're going to provide a recording of the Nini, isn't you?
Yes, I am. I even mentioned that I'm gonna start our own YouTube channel where we'll be pushing all the recordings there. So if you need to go back and just rewatch it a million and one times if you want to, it will be better to keep track. Yeah.
Okay. So there's a question. How do I get pip on my computer? So once you have installed Python, it comes with it for as long as you've added Python to path. So there was that step when you're installing Python that I had shown earlier. So I'm going to repeat. So if you have your setup, there's a checkbox at the bottom that says add python.exe to path. So you are going to click on that, then install. Don't install directly. This will not add Python to path. The idea of adding Python to path, the idea of adding Python to path is to make it accessible via, you're going to make it accessible via the terminal or command prompt. So if you are using Anaconda, I think Anaconda can has it already. There's an interface by Anaconda that can let you install it directly. But for the sake of ease, let us use the one provided by Python. How do I tell notebook has been installed? So the process, once it's complete, will give you this, and if there are errors, it will flag. The errors will be flagged. Now, to tell whether you have installed notebook correctly or whether the process has been successful, you will run on your terminal or command prompt. You will run Jupyter Notebook like that, and this will start Jupyter Notebook. I believe we can all see this new window that has popped up here. So from here, you can navigate to any window that you want, or to any folder. So this is Jupyter Notebook itself, and I'm going to open it in a specific folder. So for now, I will close it. So I'll close it. I'll open, let me go to documents, and I'll create, let me go to this other one. I'll create a folder for geocode like that. You can name the folder anything you want. So for this, I'm just using it to store the the various scripts or commands that we are going to be using. So once you have created a folder, on top there, here, you type in cmd for those that are using Windows. For those that are using Ubuntu or Mac OS, you can right click on the folder and open terminal. So once you are here, we will need to create a virtual environment. And what is a virtual environment? A virtual environment necessarily helps us to keep track of the various packages. Bob,
Just a minute.
Val, you had something to say, Ama?
No.
Okay, so we have opened command prompt, and now we want to create a virtual environment. And like I've said, a virtual environment enables us to keep track of the various packages that we are using, so that we don't have to use, um, uh, the package management that comes with Python. So this is particularly important if your goal is to end up deploying the models that you build. So it's highly encouraged that you work with a virtual environment. So now that we have installed Python into our system, we are going to run a command that is specific to Python that will enable us to create a virtual environment. So under here, I'm going to type Python -m then env. So the structure is Python, to call Python, the Python executable application, and then venv refers to virtual environment. Then this one here is the name of the virtual environment. So you can change this to any name. You can call it geocode end or any other name. So for now, I will change this to end because this one is a standard that I've been using for quite some time. So once you have that, you click enter and this will create a virtual environment for you. So I'm going to also pass this here. So to confirm that a virtual environment has been created in your folder structure, let me zoom in. So in the folder that we had, the geocode folder, you will see env. So this is the virtual environment that you have created. And it will look like this. So we would be interested in these two, lib and scripts. So here, this is where the packages are going to be stored. Under lib and scripts will enable you to activate or deactivate the virtual environment. And as you can see, we have a Python executable here. So this one kind of installs another version of Python that is only accessible via the virtual environment that you have created. So now we will need to activate the virtual environment. So to activate the virtual environment, in the terminal that we had earlier, we are going to type this. We'll say env, and env is the name of the virtual environment that you had. Scripts, then activate. So I'm going to also copy this. There. So it's in the chat. So the name of the virtual environment in my case is env. So you can change it to the virtual environment name that you used. So if you click that, you will notice that here it starts with bracket env. So I'm going to install the very first package that we are going to be using. And just to confirm, if you open the virtual environment and go to lib and site packages, you will see that there are very few packages in the folder. So in the terminal, I want to install pandas, for example. So here I will run this. So pandas is one of the libraries that we are going to use. So I'm also going to share this. So let me just type it. So one thing you need to note is that first you will need to activate the virtual environment. Once you have activated it, you will use the command that I have provided to install the packages into your system. So you can see there that I have pip python -m pip install pandas. So this will install pandas. If you want to install any other thing, you can change it to any name. So for example, if I run python -m pip install maths.d. So this will install now the package matplotlib that will enable us to draw or to plot graphs from the data that we will be interacting with. So if you go back now to the virtual environment, env, then lib, then site packages, you will see that the number of packages have increased, and we now have pandas and its subdependencies. Okay, so now we will need to install again. We'll need to install Jupyter Notebook again. And the procedure is the same. We're just going to type in python -m pip install notebook. So while we wait for Jupyter Notebook to install, do we have any questions? Okay. So from here now, we will, what do people mean? I see it common in most of the lines. So pip is a command by Python that enables Python to install packages. So as you can see, for all commands that I am running to install a package, for example, I start with there's a pip command, and if you go to the virtual environment that we have created, and then you go to scripts, you'll be able to see pip somewhere. Yeah. So pip is a Python script that enables Python to install packages. The next question, post the command. Okay. So, can you install the upgrade pip part? Sorry, I don't get the question, but uh, assuming that you want to upgrade any package that you have, you will run pip install, then you pass this upgrade. minus minus upgrade. Oh, sorry. So this should not worry you. PIP is regularly updated. So if you wish to upgrade it, you can upgrade it. If you wish to maintain it, you can maintain it. But for now, I'm going to maintain the one that I have. But the command is still is provided for you there. So if you want to upgrade, or if you get this error that not necessarily, this is not an error, it's a warning that tells you that Python has been upgraded. Not necessarily Python, but pip. Pip has been upgraded. So if you want to get the latest version of pip, you use the command that is provided there. But for now, I'm going to skip that. And we are now going to let me clear this. We are now going to start we are going to start Jupyter Notebook. So, like I said earlier, to start Jupyter Notebook, you just type in Jupyter Notebook there. Now you can see it opens Jupyter Notebook, but directly in the folder that we had. So we are in the Geocode Connect folder, and now we want to create a Jupyter Notebook file. So you will come here to New, then Python 3. This is the one that we need. So this will create an empty Jupyter Notebook file. So this is the structure of Jupyter Notebook. You can rename the file here. So you can click on the name here on top. Then you can rename it. So for this one, I'm going to rename it to Introduction to Python. Yeah. So this will enable you to run Python commands. So you can feel free to play around with what we have here. So for example, we can have our first hello world command like that. Print hello world. Yeah, Moses, you can speak. I see Moses has raised his hand. Sorry, to rename the file, the file name appears on top here once you have created the file. So you just click on the file name, and then it will take you to this place where it will open this dialog that will let you update the name, to change the name. Yeah, so that is the process. Okay, so once we have all installed Jupyter Notebook, I believe now we can proceed to learn the basics of Python. I can see the 1 hour time is up. So this is what I want each one of you to do for the rest of the week. You will visit this site. Visit W3 schools. visit W3 schools. The link is provided there. So for the rest of the week, kindly go through the material for Python, and here you will learn the syntax. You learn things like comments, variables. We learn about data types. You learn numbers, casting, strings, so on and so forth. Yeah. Then next week we'll have a recap where we'll go through the basics, where we will now interactively learn about the data types. We learn about the various data structures. We learn about if-else statements, loops, and functions. Yeah, I believe that is what we may need to have a grasp on while we learn machine learning. So unless there is a question, I like to stop at that. Do we have a question?
Okay, thank you so much, Kevin. One thing I can actually try to maybe advise all of us is, I know for some people this might be a lot to grasp in like at a go. However, that's always the first step to coding, right? Don't let it prevent you to learning more, because one thing about coding, one thing about doing or rather becoming a veteran in this platform, or rather in the coding platform, you just need to always try. You need to always push yourself. You need to always practice. Practice is always like the main thing above it all. So I don't know about you, Kevin, but I was thinking we could actually make it. I don't know about your schedule. I think we're just gonna discuss about it. However, we can make it a 3 day session, or rather a three. It's awkward to say a 3 day session, or rather a 3 time session. However, we are gonna talk about it together, and we're gonna give a response to the people, so that we can do maybe for this week. Guys, try to install the Jupyter Notebook, try to implement and try to practice a lot with using your command prompt. I know we have veterans in coding here, and they can tell you it's never easy to code, it's never easy learning it on the first day, but your consistency, your resilience is all that matters. So try working on the Jupyter Notebook, try downloading it. If you have any question throughout the week, kindly do not hesitate to drop it in the group, because I know there are people who are willing to help you out. Other than that, I do not know if there's anyone who has any question. Oh, and also for W3 schools, I've seen that recently they've implemented the video part about it. Uh, and I feel like for W3 schools, they're a bit easier to understand, you know? So practice, be consistent, master the basics, because the basics, with the basics, you can be able to handle any sort of code that you're getting, that you get along the way, whether in GIS, data analysis, all all along. So I don't know if there's anyone who has a question or any feedback on how the training was. Would you want more of this? Yeah, what's your feedback on how the training was? I think I can just drop in a poll, and or rather I will drop in a poll in the group, if not wrong, so that you can give me your views on how the session was. This will improve us when we carry out other trainings, because this is going to be more of trainings on our end. So yes, so I don't know, is there anyone else who has something to say? Even a feedback is okay.
Yeah, before we get the feedback, I'd like to insist on this first point. You need to master the basics when you are working, especially when you have interest in these big terms. We hear people that are interested in web development. We hear people that are interested in machine learning. You can't learn machine learning without learning the basics. It's a really big concept that everyone needs to. You need to take it serious while you are learning how to code. And out here, when people are applying for jobs, for example, even though you are applying for a job, even though you are applying for a job as a machine learning engineer, the kind of questions that you are asked during an interview will be questions regarding the basic concepts of whatever language it is. So you really need to master the basics. Don't be in a rush to learn the big terms. You hear someone uh, who claims that they are a very big machine learning engineer, but when you give them a simple code, they can't really work around it, or a simple task that deals with data structures. So it is really, really important as we proceed in this journey to learn machine learning together that every one of us, even though we are not going to go deep into the basics, you need to really learn the basics while you are learning even not while, before you learn machine learning. So in the next week that we are going into, if you find time, kindly go through the basics of machine learning. And as Valentine has posted there, you also need to be patient. I started learning coding in 2019. By then, it didn't make sense to learn coding, but I did it anyway. Along the way, you will realize that even how you are thinking around problem solving changes. You can think around a problem using code, for example. And it's a really good experience to have. And you cannot have that experience if you don't have mastery of the basics. So yeah, uh, coding is not easy, but it is easy as well. So you just need to be consistent. Um, take your time. Yeah, you will not be a machine learning engineer in 1 week. So I believe this journey will span more than 3 months. And I believe by the end of the 3 months, we'll be able to demonstrate mastery of machine learning, and we'll be able to demonstrate mastery of the basics of Python. Yeah. So thank you. I look forward to interacting with all of you, and I look forward to passing the knowledge that I have to everyone. Thank you.
Thank you so much, Kevin. That's it for us. And happy learning, everyone. So, yeah, bye bye.
Usifungie mtu ako na swali.
Okay. Anyone with a question? This is a free platform, by the way. That's why we formed GeoCode Connect, because we want many people. We have actually endured what young geospatial people face, where you don't have people to interact with, where you don't have people to share your problems with, where you don't know where to start when it comes to coding, or rather, maybe things are, it's a lot to be in the geospatial industry. And we get that a lot. And that's why we started this, just to partner with every young person in our industry and try to learn with each other and also move forward. Also, I've been getting a lot of questions on people, if I can get them or rather secure them with internship positions or even jobs. I will say this in the kindest way possible. I'm not in a position to. However, at Geocode, we try to send as many applications as possible that we see fit, Please be encouraged. We understand the world out here is not as easy to navigate as it all seems. And we know there's some people who might make it seem easier to navigate, and we know it isn't. Kindly have faith. Try to look for internship positions, attachment positions. You never know. There are people who also suggest that you may also go the old school way. Go to the, how is it called, to the offices yourselves. You never know. Just try out your luck. So I use LinkedIn a lot. Try to follow informative people on this websites, that is LinkedIn and Twitter. We have like big geospatial veterans out there, and they normally also share opportunities out here, and try to encourage yourself as well. So yeah, so I do not know. One last round. Does anyone has or rather have anything to say? The floor is yours. Okay, then I think we will end it there. Kindly try to practice a lot on the Jupyter stuff, and also introduction to Python. Something Kevin has said and has really made some sense into me looking back, because I also started learning how to code, I think, in 2019, 2020. And he said a very profound thing: it never makes sense at that point. However, the beauty about it not making sense is at the end of that journey, you're able to understand the basics because you've gone through the basics like a million and one times. So even when you're given, let's say, a project, or rather you have a longitude and latitude data set of a lot of places, and you have to clean that data, you're able, with those basics on Python, you can be able to easily navigate it, without using the Excel and all that. So have courage, guys, and be patient. So I think we're going to end the session there. Have a blessed night, you all, and thank you for joining in. Let's meet next Sunday. Bye bye.
Bye.